Hey folks, wanted to make a video here to address a common question that I get, which is in regards to when we're doing transformation of functions, there are two ways that you can report your final transformed function. And the two different sets of instructions are going to look something like this. So I have a few examples planned to address this issue and hopefully shed light on it. So as an example, we'll call it number one. I didn't number it, but we'll call it number one. So let's suppose that we have this original function p of x, and for the following problem, we're going to create a new function whose name is going to be t by transforming that parent function. Remember, her name was p. Using the transformations stated. Okay, so for this first one, we're going to do a vertical stretch by a factor of 3 and also a vertical shift down 6. Okay, so one of the ways that we ask you to report these answers is writing the new function as a function of the original. And when I call it the original, I'm just calling it p of x. I don't know what kind of function it is. Is it a line? Is it a squared graph? Is it a cubed graph? I have no idea. I just know that his name is p. So when you do it this way, you obviously have your new function, so t of x, this is the transformed function, and t of x, the new one, so new transformed function, is going to be equal to, well, p of x, remember p of x is the original, p of x with whatever alterations are necessary. So in this case, it's a vertical stretch factor of 3 and a vertical shift down 6. So a stretch factor of 3 is going to be a multiplier that gets applied on the outside to the outputs of p of x. And then a vertical shift down 6 will just be a literal subtraction of 6 on the outside, again, because it's to the outputs of this creature named p. Now, and that's it. That's the answer for that. T of x is a function of p of x. It has the letter p in it. So if a stranger were to walk into this space right now and look at my screen, all they would know is, oh, cool, you've got some transformed function. His name is t, and he is, 3 times as much and also 6 units less than the other guy. His name was p. They have no idea what kind of function this is. They don't know if I'm transforming a line. They don't know any of that. All they know is I've transformed some creature whose name is p. That's it. Well, for the alternative way of writing it, the other set of instructions for this is still creating a transformed function whose name is t, but this time it says as a function of x. And by the way, this creature named p, it turns out he's been a cubic this whole time. We didn't know that before, but we know that now. So when you're writing your equations the other way, you still have this new transformed function. Oops, not f. I'm so used to f of x. This new transformed function whose name is t, only now you're applying these same alterations, timesing by 3, subtracting 6, but now you're applying them to this guy. I am not going to write the letter P anymore. Instead, I'm going to reveal to the world what P has been this whole time, and that is a cubic graph. So I'm still going to have my outside multiplier of 3, only now it's going to multiply that entire cubic function. I'm replacing the p of x now with who he really is, and that is a cubic. So 2x cubed. And don't forget, yes, minus 6 as well. Now, for me, you can just stop there. You've already applied the transformations. As far as I'm concerned, it's done. If you really wanted to simplify it, you could. In this case, the 3 is getting multiplied to the coefficient of the 2x cubed. So in this case, it'll turn into 6x cubed and then just minus 6 on the end. So whichever, it doesn't matter. But again, you don't have to worry about simplifying as long as you get this far. then it proves that you've applied the transformations correctly. Okay, let's look at that same set of instructions, but for a couple different scenarios just to make sure it's making sense. So for this next one, we have a vertical shift up 5, a vertical reflection, and a horizontal shift to the left. Okay, so same as before, T of X is my new guy, my new guy. And for this first one, it's as a function of P. I have no idea what kind of formula P is, and that's okay. I'm just going to keep it generic using his function name, and I'm still going to apply the necessary transformations. So on this one, a vertical reflection means that there's a negative A value on the outside. And since it doesn't say stretch or compress, I know it's just a negative 1 technically is what that is. You could just put a negative P of X, but I'm going to put -1 just to kind of be explicit. And then as I get ready to write P of X, I'm looking back. What else do I have here? Oh, a horizontal shift left 2. Okay, so horizontal shift, that's on the input axis, the X's. Therefore, it has to be inside the parentheses, inputs inside, and it's to the left 2, which means that inside the parentheses would have said X plus 2. So that would be that. And then also a vertical shift up 5. So that means there's a plus 5 hanging out on the end. And for this one, again, that's it. I don't even know what P is, and I don't care at the moment. I just know that whomever he is, he's going to get transformed according to those transformations. Now, here comes the other way of writing it. This time, same thing, transformed function, but as a function of X, not as a function of P, but as a function of X. So in this new answer, I am not going to write the letter P. No. Instead, I'm just going to reveal what P has been this whole time. So remember up here, we said that the entire function was going to get timesed by -1. Okay, well, that's still going to happen. But now it would say -1 times all of this. So this whole thing is what's going to get timesed by -1. Now I'm going to be sneaky and I'm going to simultaneously apply my shift to it, my horizontal shift, my X plus 2. So I know it's still going to say 3. I know it's still a root, but now here comes the horizontal shift. Remember how the X's are going to turn into X plus 2's? Well, now's the time when we swap that out. I'm going to extend the radical to make sure it's crystal clear that my X's are on the inside input. And I'm going to say X plus 2. And then, of course, -4 is still there. So that's the whole P function with, of course, my sneaky substitution snuck in there. And then don't forget, we also had the vertical shift up 5. So there's also a plus 5 chilling on the outside. Okay, so again, for me, if you get this far, you're good. Like, as far as I'm concerned, that's it. That's the answer. If you wanted to simplify this one, just to kind of give, I know I've got some curious students out there who want all the things, and I love it, so I'm here for it. So the -1 is on the outside. It gets applied to the outputs. So the -1 changes the 3 to a -3. My inputs are not changing, X plus 2, but I would also have to multiply the -1 by the -4. Remember, that's going to cause that -4 to become a +4. That's the reflection piece that's hiding behind the scenes. So now it would be a +4. And then also don't forget the +5 is our new vertical shift. So on this one, if you wanted to take it all the way, the outputs are now a -3 multiplier. The inputs have been shifted, and your final value on the end is indeed going to be a 9. So that's where that one would land if you wanted to simplify it. Again, for me personally, you just don't have to. So that's what I'll say about that. Okay, one more just to make sure. Here we go. So part B. I guess I meant part C, didn't I? Well, whoever said a math teacher knows their alphabet, you know? Okay, part C. What do we have? A vertical stretch by a factor of 10.5, also a vertical reflection, and a vertical shift down 4. Okay. Transformed function t as a function of p. Okay, so this is the generic way. So t of x equals, I have no idea what p is, but what I do know is they're going to have a multiplier of 10.5. By the way, that multiplier is negative because you also need a vertical reflection. That's going to happen to the outputs of P. What else is going to happen to the outputs of P? Oh, a vertical shift down 4. Down 4. There you go. Done. I've stretched it by a factor of 10.5. I've made the multiplier negative so that it reflects. And I have a -4 on the outside of the notation because the outputs are going to go down 4. And that's it for that one. If you wanted to write it the other way as a function of x, once again, this is where your final answer will no longer have a p in it, but instead you reveal to the world, it turns out this whole time it was quadratic. Guess what? She's quadratic. Okay, but the transformations are still going to get applied. So what do we have? We have a -10.5 that gets multiplied to that entire function. So 2x squared plus 2. And then also a -4 trails on the end. For me personally, stop there. Call it a day. You're done. If you wanted to go further, that -10.5 is going to multiply. In this case, the 2 becomes, what is that? -21x squared. And then this 2 right there also gets multiplied. So now it's just a -21. That would be the reflection and the multiplication scalar on the entire outputs of the function. And then, of course, don't forget your -4. That also is going to bring it down 4. And if you simplify this just a little bit, it'll be -21x squared. What is that? -25. And that would be t of x as a function just of x. So yeah, those are the main two ways that we ask for it. The main takeaway here, guys, is that if it says as a function of p or whatever the name is, a function of h of x, a function of g of x, a function of q of x, you're not going to reveal what that actual formula is. You're just going to call him by his function name, in this case, p, or whatever letter is indicated. But if it says as a function of x, that's when you drop the function name and instead reveal what they are. Are they a line? Fine, you're shifting a line. Are they quadratic? Fine, you're shifting a quadratic. In this case, this one was cubic. Fine, you're shifting a cubic. This one, as it turns out, was a root function. Fine, you're shifting a root function. And also, FYI, I realize we have not learned cubic functions or root functions yet. And that's totally fine. That's not the point. You don't have to know exactly all the characteristics of a root function to still at least be able to comprehend how it gets altered based on the given transformations. We will do quadratics and cubics in this next unit. So stay tuned. We're getting there. But don't let that be your sticking point. Don't say to yourself, oh, I don't know what a cubic graph looks like. Yeah, I hear you, and that's okay. That's not the point right now. Notice I'm not asking you for characteristics of a cubic graph. All I'm asking you is, can you take a given function, the parent function, and transform it? That's all this chapter is about, is transforming things that are given to you. So hopefully that makes sense and helps a bit. And yeah, you guys know how to reach me. If you have any questions, please reach out and we will be in touch. Thank you.